about the SLD, single line diagram for the distribution of electrical power to a residential building. Okay, so now for any residential buildings there will be a RMU, that is ring main unit. And what is the function of, means what is the RMU? Okay, so this is what typologies of the electrical what we can say electrical distribution system. Okay, this is the one of the types depending upon the scheme of connection. Okay, so there are three main schemes of connections of the inner distribution of the power. First one is the radial system, second one is the interconnected system, and the third one is the ring main system. Okay, so this comes under the ring main system. Okay, so this is a ring main unit. So why it is like that? It forms a ring. It forms a ring, suppose if means some fault is happen or occur at some point, then that will be fed by some other location. So this is the function, means that the reliability will be increased, and what happens again, the supply may means the breakdown will not happen in that case. So that's why the RMU is connected here. Okay, so you can see the at the two different location the source is given, or the source supply is taken, and it is given at a two different location. You can see here is the incoming line, incoming supply, and this is incoming supply, so at the two different location. And now it forms the ring, like, okay, like that. Now, so you can see this is the supply incoming from the source. Okay, so source may be some MSADCL from MSADCL supply substation, or some substation which is built in our premises. Okay, and the incoming for that substation will be some MSADCL supply. Okay, some MSADCL supply from MSADCL substation. So now you can see this is 11 kV HT supplies coming from the source. Okay, so HT supply, the voltage which is equals to 11 kilovolts or greater than 11 kilovolts, it comes under the HT, high tension, and again above means like 33 kV or 66 kV, like that, it comes under the EHT, extra high tension supply. Okay, so now it's going means the supply is coming through this cable. This cable is of, means one run is there, and cable is of 3 core 300 square mm. Okay, and HT earthed, this is aluminum cross linked polyethylene armored cable. So it's going to what, going to the RMU1. Now we can see here the RMU1 is here, RMU2 is there, and RMU3 is here. Okay, so all these are connected. You can see this is the incoming supply to this RMU, and this is outgoing of the RMU1, and now it's connected to the incoming means it's incoming for the second RMU, and now you can see this is the second means outgoing of the second RMU, and it's the outgoing of the second RMU is incoming for the third RMU. Okay, and again it's going back to the source. Now you can see here whenever it enters into the RMU, there is a load break switch. Okay, LBS, load break switch. So load break switch is nothing but the combination of the circuit breaker and the isolate. Okay, yes, so you can means what is the specific function of this LBS, load break switch? Okay, so you can see the rating 630 ampere, 11 kilovolt LBS. Okay, at the incoming in the incoming okay, also, and at the outgoing also, you can see the LBS. So what I told, that this is the combination of the circuit breaker and the isolator. So the isolator works under a no load condition. Whenever the load is off, okay, at that time only isolator can be operated, and the circuit breaker can make or break its contacts under loaded condition and under unloaded condition when load is off. Okay, so both the functions can be done by this LBS means it can operate under a loaded condition as well as it will under means works under the means loaded and unloaded condition. Okay, So now you can see there is a bus bar is there, copper bus bar is there. Okay. Okay, so this copper bus bar is of 630 ampere three phase. Okay, so three phases will be there, means so three bus bar will be there, and 16 kilo ampere is the short circuit rating. Okay, for that means for 1 second, it can handle the 16 kilo ampere current. Okay, yes, means without any damage. Okay, for 1 second. Now the outgoing is there, outgoing feeders are there from that bus bar. So you can see now here we connected a SF6 circuit breaker. SF6 circuit breaker having short circuit rating 16 kilo ampere and the current rating 630 ampere and voltage rating of 11 kilo volt. Likewise here another feeder and the same SF6 circuit breaker we connected in that. Okay, now what happens, suppose we will take this RMU. Okay, same is there. Now you can see these cables of 11 kV one run. Okay, this one run cable 3 core 95 square mm, and this the cable sizing will be depends upon the load, whatever load we connected. Further that by using that data we can calculate the how much square mm cable will require. Okay, now we are connected here a transformer 1, that is a dry type distribution transformer. This is a step down transformer, delta star connected transformer. Primary is connected in delta and secondary is connected in a star with the neutral grounded. Okay, right. So this is the comes under the vector group of DY11. Okay, DYN11. So now this is a transformer second, and this rating is showing some 995 kVA, but it's not like that. The rating, standard rating of this transformer will be 1000 kVA, that is 1 MVA. Okay, 1000 kVA, which is equals to 1 MVA. So both transformers having the same rating. Now outgoing is 3 phase 4 wire. Okay, but here the number of cable runs are taken out from the that is low, means we can say low side of that transformer, low voltage side of that transformer. So you can see this is a 20 runs, means 20 cables of one core 300 square mm aluminum cross linked polyethylene armored cables. Okay, so likewise same here you can see again this cable is going like that. So here is also same 20 run. Okay, and 300 square mm aluminum cross linked polyethylene armored cable. Okay, got it. So it's going to some main LT panel. Okay, on that panel the different two towers supply is means fitted. Okay, right. So you can see here you this is going that cable is going into the main LT panel 1, and you can see the connected load is something 2391 kilowatt, and this is the demand load. Demand load is 795 kilowatt. Okay, now so what is connected load and what is demand load? So connected load is total number of connections connected to that particular feeder. Okay, so that is what the connected load, and demand load is nothing but the at a one time how much maximum, or we can say the maximum load that can be on at a one time, at a particular time, that is a demand load. This is means this is the maximum load that can be on, that can be connected, or that can be on at a particular time. Okay, so that is a demand load in kilowatt. Now you can see this is a 3-phase master meter in that panel, and now you can see this is a different indicators in that panel. You can see the indicators as well for the phase. Okay, RYB and the on off tree. Okay, now we connected here the long time. So you can see this is the ACB. Okay, ACB, air circuit breaker, having short time or the short circuit current rating of 50 kilo ampere. 1600 ampere is the current rating, and this is a short circuit current rating 50 kilo ampere. ACB, 4 pole ACB. LSIG is nothing but the long time, short time. Okay, what is this LSIG? Long time, short time, instantaneous and ground fault protection. Okay, this ACB gives the protection against the long time, short time, instantaneous and ground fault protection. Okay, so this is LSIG ACB. Now it is connected to the bus bar, and the bus bar having the rating of 1600 ampere triple pole neutral, means we have the 3 bus bars for the phases and 1 bus bar for the neutral. Okay, so this is voltage rating for 15 volt AC, 50 hertz, 50 kilo ampere is for 1 second is the short circuit current rating. Aluminum bus bar. Now you can see in this panel we connected aluminum bus bar, and in RMU we have that copper bus bar. Okay, now so there are different feeders are there. Okay, different outgoings are there. So you can see the ACB is connected here also. ACB 4 pole ACB, 36 kilo ampere is the short circuit current rating and 1000 ampere is the current rating. Now we connected here a 3-phase master meter. Okay, and now it's going to some panel. Okay, some panel, it will go into the firstly it will go to the panel via this, means through this cable, having a cable size of 2 run, 3.5 core, 300 square mm aluminum cross-linked polyethylene armored cable. Okay, now it's going to the isolator pan or some panel of some tower. Okay, so you can see here a connective load and a demand load. Now it will go firstly the panel, and in a panels there is some ACB. Okay, 4 pole ACB, on off trip is the indications, and now the bus bar, it connects to the bus bar. Okay, now this is the bus bar ratings, and now from the bus bar there is a different outgoings are there. Okay, the 1 2 3 4 5 6, okay, 6 outgoings are there, and these 2 are the spares. Okay, so here we connected firstly 250 ampere 4 pole MCCB molded case circuit breaker having rating, short circuit rating of 25 kilo ampere, and current rating is 250 ampere. Now it's going to the through this cable, means outgoing cable is of 3.5 core, 120 square mm aluminum cross-linked polyethylene armored cable. Now it's going to the some MCCB. Okay, MCCB means again there is some horizontal panel. In that there is a the incoming will firstly go to the firstly go to the MCCB molded case circuit breaker of 250 ampere 4 pole. Okay, so again that there is a bus bar, aluminum bus bar, and from the bus bar there is outgoing goes to the some 3-phase energy meter. Now this is the individuals residents individual meters, 3-phase energy meters. Okay, so now there we have to connect some 4 pole MCB for, okay, 40 ampere is the rating or current rating, and 10 kilo ampere is the short circuit current rating. Now it's going to some flat electrical steping, and then further distribution will be there from the flats dB. Okay, so this was the SLD single line diagram for the distribution system of the resident for electrical power for the residential tower.